Okay, again, we're focused on breaking problems into pieces. And when we're thinking about a problem, often the nouns that we talk about, those become classes, and the verbs often become methods. So you've seen the Spampede game. Try and fill in what each color in the board might mean, and try and identify what classes we might need to represent this game. So try and come up with some classes and even some instance variables. So you should pause here and I'll keep going. So I thought about there's a board and board cells, like the individual cells within one of those grids. There's spam, there's the snake head, and there's these empty spaces. We're going to represent the different types of board cell using an enumeration called cell type, and that'll allow us to keep track of what type of thing each of those board cells is. And our actual enumeration is going to be a little more complicated than this because we want it to have some methods. But big picture, here's how we'll keep track of the finite set of types of cell types that we'll have. There are only these 5 types of board cell. So in our Spampede data class, we'll have a 2D array of board cells. We've made that 2D array private and tried to give it an intuitive name, board cells 2D. You'll notice here that Spampede data, the class, I didn't list it as public. So when we don't put public, what that means is you can only access it from within the package. And again, my enumeration keeps track of the different types each of those board cells could. So you can imagine that a board cell has an instance variable named cell of type cell type. Okay, what's the big O runtime to count the total number of spam? I want you to pause the video here and I'll keep going. Okay, you can imagine if I use a naive approach and I just look through every cell in my 2D array, then that's going to be height times width. That's the big O runtime. That's the answer I wanted you to get. But I also want to introduce an idea where sometimes we can store redundant information as a way of speeding things up. So here in my Spampede data, in addition to being able to look through the 2D array to see what's spam, I'm also going to keep an additional reference to all the spam cells. And I'm using a library class called linked list. That linked list is parameterized and it going to hold board cells for me. Again, this is redundant information. I already had a way I could get all the spam cells. But sometimes having redundant information allows us a performance improvement. And you can imagine that redundant information is a little bit of a pain because we have to keep everything up to date. But redundant information can sometimes provide a performance improvement. And now if I wanted to know the total number of spam, I could just ask that spam cells instance variable, I could ask that linked list, how many elements do you have? And that's going to be an O of 1 operation because that library class linked list keeps track of its size. Okay, I've got a sample board on the left-hand side, and I want to draw your attention to the fact that from the perspective of the user, it's actually ambiguous where the snake's body is. So on the right-hand side, I have 2 possible paths. So you can imagine it's not enough for us in that 2D array to label every cell as either a snake or open or spam, etc. If we're going to have the snake move along, we also need to know the order of those body parts. So I want you to pause here and think about how you would provide that additional functionality. So you should pause and I'll keep going. So in addition to the linked list holding the spam cells, I'm also making a snake cells linked list, and that'll allow us to keep track of what direction it's going. That'll allow us to keep track of the order of the cells, and we'll need that when we're moving the snake along. You can also see that on line 19, I've added something of type snake mode, and I hope you recognize that snake mode dot going east, that looks like a static final variable. Static because it's called on a class name, final because I used all caps. And we'll actually implement that using an enumeration. I also added a few other pieces of game state, such as game over, and the number of free spots that I have on my board. You can ignore those other pieces of game state, but I want you to try and draw the UML. And you should pause it here and I'll keep going. Okay, so here a Spampede data has a board cell 2D array. So you can think of that as it has many board cells. It also has 2 linked lists of board cells. One was for the spam cells, one was for the snake cells, and then it has a snake mode. And again, UML can be really helpful for this big picture view of our code. And again, I didn't draw free spots or the game over. Okay, now I want you to try and design a board cell object, and you can draw the UML or a CS60 style object or just write the class. So you should pause here and I'll keep going. So we've talked about cell type before. You can see see that on line 13. I wanted to know what type of cell it is. And as the snake moves through the board, that cell type might change. Additionally, I want every board cell to know its row and its column. That's going to be important. So for the linked list of my snake cells, I want each of those snake cells to know where they are in the grid. And if I didn't store their row and their column, then if I wanted to know where a single snake cell was, I would have to look at every cell in the 2D array to be like, are you this one? Are you this one? Are you this one? So again, here I'm storing redundant information in that row and column for a performance improvement. When we implement the artificial intelligence, so that's when the Spampede plays by itself without the keys, we're also going to be implementing a search. And so here we're also going to have an instance variable that allows us to keep track of whether we've added it to our search list. And then to do backtracking, we're also going to keep track of a parent cell, which will end up being which cell around it added it to the search list. But you wouldn't have known that those would exist, and we'll come back to them later. And again, cell type is that enumeration that we saw before, and it's actually a good bit more complicated than that because we want cell type to also have methods we can call on it. So inside of my board cell, I want to be able to get the string for my cell type. So my board cell, that's what class I'm in right now, it had an instance variable my cell type, and I want to be able to call the method on it get display character. This will be super important for our debugging so we can print out the state of various boards. Because I want that, my enumeration has to get a little more complicated. So here's a copy of my enumeration. Again, when I list out all the items in my enumeration, I put parentheses and then I'm essentially calling that cell type constructor. So the type has to match there. So I pass in a string and that'll become input character. And you can see that on line 30. So my enumeration, instead of just being 5 unique items, they also have an instance variable display character or display char and a method to be able to get that string. Okay, here I have an example of a Spampede data object. Linked lists, those are a library class, so I actually don't know what its instance variable names are, but everything else is drawn in the typical CS60 mode. The only other example is current mode. That east is actually another object, but there was enough going on here, so I took a shortcut on that one. So I want you to look at this and the code that we have for Spampede data to try and see how they relate and try and figure out, okay, this is a 2x2 board, and what are the contents of each of those cells? And again, in the board cell, you can see that the contents is actually just a shorthand for my cell type, which is actually an object. So that contents is a little bit different, and the name visited, the instance variable name visited, is a shortened version. But I want you to be able to translate between this and the Java class that we looked at before. And the thing I really want you to notice is the fact that there are multiple references to a lot of the board cells. So check out my board cell that is the head. It's referenced both from the snake cells and from my board cells 2D. And similarly, my spam cells, that linked list references my board cell that's a spam, and it's also referenced from this board cells 2D. So it's super important that these linked lists aren't creating new board cell objects, they're just referencing existing ones. And again, we're keeping redundant information around because that can provide performance improvements.